Now let's do quick review page 39. And the first question is find the volume of these gases at room condition. Alright, let's have a closer look. Find the volume of these gases at room condition, RTP. Alright, so this is quite straightforward. We can actually do it in no time. Alright, so number 1, A, 0.8 mole of methane. Okay, methane, CH4, methane. They want the volume at room condition. Volume at room condition would be 24 times number of mole. So they mentioned in the book is 0.8 mole. So 24 times 0.8. Alright. So 8 over 10, 0.8 is 8 over 10, so 4 over 5. Okay, so better use calculator to be more accurate. 24 times 0.8. That would be 19.2. 19.2 dm cubed. How about B? How about B? Again, at room conditions, B, the only information that they gave us is 9.03 times 10 power of 23. Alright? Atom of helium. Atoms of helium. They tell us so much of what alphabet should we represent this number? This big N. And do you remember number of mole is actual over standard? And because of this, I can write 9.03 times 10 power of 23 divided by 6.02 times 10 power of 23. I can do some elimination quite easily. This 9.03 divided by 6.02, that will give you a value of 1.5. Okay, so the number of mole is 1.5. We can write it here. Number of mole is 1.5 mole. Now use this information for you to find volume at room condition, RTP. Alright, most of the time you don't have to write this. What you need to do is RTP is 24, so 24 and start a new page. Remember the number of mole. Number of mole is 1.5 mole. So the volume of helium gas would be 24, and so you have 24 times 1.5. That will give you 36 dm cubed of helium gas. Alright, let's move on to question number 2. Right? Question number 2, calculate the mass of 1.505 times 10 power 24 molecules of hydrogen gas at STP. Alright, so what they really want is, you see, they want mass, put mass question mark. Always do that in question. Here, this one is big N. And then they say this molecules of hydrogen gas, so it will look something like this. Alright, so what other information can we get? Remember to write all this down so that it's easier for you to do the question later. Calculate the mass of 1.505 molecules of hydrogen gas H2 at STP. Okay, I sense that the question has some error, but nevertheless, let's try to do it. Okay, what information given? Number of mole, number of molecules, yes, 1.505 times 10 power of 24 molecules of hydrogen at STP. Okay, at STP. So can we find the number of mole first? Actual number over Avogadro's constant, actual over standard. So that would be 1.505 times 10 power 24 divided by 6.02 times 10 power 23. I'm sure you will get a figure of 1.505 divided by 6.02. You get 0.25, but there's a 10 behind, so it's 2.5 mole. 2.5 mole. Okay? Let's just imagine that the question is not wrong. They ask us to find mass. Okay? We can find mass quite easily. Let's use rate. You want to find mass? Remember, number of mole times molar mass. Isn't it simple that I just put 2.5 times molar mass of hydrogen gas is actually 2. You know why 2? Because 2 times 1. 2 pieces of atom. So this will give you 5 gram. But if we consider the question has some error, I would just say that because since they mentioned STP, I would like to stress that you could actually get the volume. Just use 2.4 times the number of mole. Now 2.4 times 2.5. Okay, my mental arithmetic is not that good. I still need my calculator. So you get 56. So you get 56 dm cube of hydrogen gas. Alright, so let's move on with question 3. Okay, let's move on with question 3. 3 dm cube of an unknown gas has a mass of 6 gram at room condition. Find the molar mass of the gas. Alright, so let's do some summary first. See, whenever you get question paper, write down this V, unknown gas, doesn't matter, 6 gram small m. Okay, find the molar mass, big MR. Can you put question mark? Alright, so with this question in mind, we would like to go to the whiteboard. Now let's put together the information again. It tells us it has 3 dm cube of unknown gas. So this one I'll call it V. And the condition is room condition. Okay, so I put RTP. Then the mass of the gas is actually 6.0 gram. So I'll call it small m. And then they want you to find the molar mass. Okay, very simple. You start off with the 3 dm cube. Remember, at RTP, you have 24 times number of mole. Can you put 3 equals to 24 n? Sometimes you can start off with this also. Number of mole equals to actual volume over standard volume. Alright? Doesn't matter, both method acceptable. So what you do next, number of mole is 3 over 24. 3 over 24, if you use calculator, that will give you 0.125. 0.125 mole. Now you keep this information and we're going to go to next page. Just remember the information, 0.125. Now, number of mole, 0.125 mole. The mass is given as 6.0 gram. Now we need to use another formula which involves the actual mass over the standard mass, which is molar mass. Because molar mass is something that you're looking for. You're looking for this. So you need to write molar mass equals to the actual mass over number of mole. So this actual mass is 6.0 gram, and then this mole is 0.125. Now 6 divided by 0.125, that will give you 48. So the molar mass of the unknown gas is 48, while the unit should be 48 gram per mole. Okay, gram per mole. You know why? Because I could put this gram here and mole here, and therefore I get the unit of gram per mole. Okay.